there, here are the full solutions for this week's Riddle Shorts. And if you are helping a middle schooler with their homework, I'm going to show you the method that teachers expect their kids to be doing for this last problem about average speed. So this jacket you've been looking at, full price is $80. It's 30% off sale, and you get an extra 20% off at the checkout because you got a VIP card or something like that. So most people are going to add the 2% and think they're getting a 50% off. So they believe they're going to be paying $40. This is not how the percents work when you stack them on top of each other like this. So here's what's going to happen. You're going to take 80 times 0.7. Where did I get that? Well, I took the 30% off away from 100%. If I'm going to use my calculator on my phone in the store, I just figure out what the decimal is going to be. So 80 times 0.7 is going to give me 56. That's with the 30% off. Then when you go to pay, they're going to use the 56 as the base, not the original 80, smaller base. You're going to take that times 0.8 because it's another 20% off, and that's going to get you the 44.80. This is the final price. It's a little bit higher than the 40, right? This sort of thing tends to favor the store. So how much did you really get for a discount? That's a pretty logical question. People are going to want to know, what did I actually get here? So take your 44.80 and divide it by the original price of 80. Turns out that by the time this was all said and done, you paid 56% of the original price, which means you ended up getting a 44% discount by combining the 30% first and then taking an additional 20% off that. Count all the cubes. The way you get these wrong is you just count the cubes you see. Your intuition about the fact that there's some cubes on here that you can't see is correct. Pull those apart. So just count up the cubes. We end up with 9 plus 6 plus 2, and that is 17. This would be a good one for little kids who are still working on their spatial reasoning. We have a trip that we're going to make. It's the same route and the same distance, although they don't tell us what the distance is. And in a minute, I'll show you why that doesn't even matter. Going there, we go 60 miles per hour. And coming back, we do 40 miles per hour. We know in real life it doesn't work like that. You're not on cruise control the whole time. But with speeds that are changing, that's calculus. We're not doing that. We're just going to do this problem. What a lot of people are going to do is they're going to add the two speeds, divide by 2, because they're going to take the average of the speeds, and they're going to say that the average speed for the entire trip is 50 miles per hour. However, that is not true. That's averaging numbers. If you want the average speed for a whole trip, you got to look at it a little differently. Your average speed is actually your total distance divided by your total time. So in order to be able to get at this, we have to have some number that we can use for distance. It's going to be the same in both directions. So pick a number that's easy to work with. Well, if I'm going 60 miles per hour, I'm going to think that the distance each way is 60 miles. I'm going to do that one. I could have picked any number I wanted to. I just want to make the math easy, so I went with that. So when you are going there, you're taking your 60 miles, dividing it by 60 miles per hour. It's going to take you 1 hour to get there. And when you're coming back, that same 60 miles divided by 40 miles per hour means your return trip is going to take longer, right? That's going to be 1.5 hours. So the entire trip was 2.5 hours. The total distance is actually 120 miles because you went there and then you came back. So it's 60 miles both ways. So it's 120. The average speed is going to be your total distance by time. Again, so let's take the 120 miles and divide it by the 2.5 hours, and we get 48 miles per hour. Average speed is time-based. So that's what messes it up. But we came up with an estimate of 50 miles per hour, and the actual answer comes out to be 48 miles per hour. So this is going to work for us totally. But if you are helping a middle school student, it's not going to work for them because that is not what the teachers are going to expect. So here, this is what their problem is going to look like. No pretty picture, just this ugly word problem on a worksheet. So let me show you how to help them get through this. They have to read this. You read the problem and you see right away what the thing is. But remember, middle schoolers don't drive, so they don't have the same real life experience here. So you're going to have to help them kind of understand what's happening. Have them make themselves a little picture so they can see what's going on. You have 60 miles an hour going in one direction, and the exact same distance going back again is 40 miles per hour. The thing that they're going to not know is that you have to come up with your own distance. So if you're coaching them, don't tell them which one to pick. Just let them think about it for a second using these speeds. Have them say miles per hour out loud, and they're going to come up with the 60. You might have to help them a little bit with some coaching here, but that's where you want them to go. That'll be the big sticking point right there. Then from there, they have to show their work. You already know the math. If you skipped ahead and didn't see what the speed trap is here, go back and look at that. But this is the math worked out and what it would look like on a worksheet. The kids have to show this. And here's the reason why. When they're in elementary school, the focus is on getting correct answers. Middle school is focused on the process. We're helping kids get ready to be able to do high school math. If your kid doesn't write out their work in a way that the teacher can follow and see their process, they're not going to get full credit for these things. In middle school and high school, teachers do not grade mental math. We are training people how to think. So they got to see something like this. Now, it doesn't have to look exactly like this, but they have to be able to follow the process. When you first look at it, you don't make the connection, but a math teacher does. We're getting kids ready to understand a concept called slope in algebra. It's a ratio of how something is changing, and whether it's changing over time or like slope is rise over run. You may have remembered that. It's the change in y over the change in x. It's the same concept. So we're trying to get the brains trained to start thinking like this. When you're coaching them, you don't say things like just write the answer. You want to say things like show where you got that total time. How did you get that? If your child is going to lose points on a problem like this, it's not going to be because the answer is wrong. It's going to be because the structure isn't visible. These riddles are going to be posted starting on Monday, and every Saturday I'm going to have the solutions for the upcoming riddles with a little bonus of a teacher translation so I can help you help them. Thanks for watching, and I'll see you next week. Bye.